So let us continue with the convolutional encoder. So that is with respect to the code tree, how we need to write the code tree, and from the state diagram we came to know how we can write the code tree. That means how a convolutional encoder can be represented in terms of a code tree. So now using the code tree, so we are going to write one more diagram which is called as the Trellis diagram. Okay. So before that, so let us discuss about the code tree and the state diagram. So from the state diagram as well as the code tree, how we can write the Trellis diagram and what is the importance of Trellis diagram. So now, so this is the code tree what we have written. So for the state diagram, which is shown here. Okay. So now as you can see, we have 7 states here. So the given message sequence is 10111. Okay. This is the message sequence. So now looking into the state diagram, so we are going to write the code tree. So now we are starting from S0, initial state. So S0 with input 0 and input 1. So if the input is 0, so it goes to S0 state. If the input is 1, it goes to S1 state. So and I told in the previous class also how we are going to write this code tree. So now the given message sequence is 10111. So now whenever your message sequence starts from 1, so your transition begins with respect to downward direction. If suppose if the message sequence starts from the input 0, then the transition is going to start upwards. So that's why I have not written here the rest of the sequences here. So this also has to be written. So but we are interested with respect to the downward sequence. So that's why I have written the code tree with respect to the downward transition. 11101. So for this, so with input 1, so we have the output 1 1. So next input is 1. So if the input is 1, so it has to make a transition downwards. So what is its output? 1 0. It is reaching S3. So again the input is 1. So it makes a transition downwards. It is 1, input 1. So again input 1. So the output is 0 0. So then it is 0 1. So here for input 1, the output is 1 1. So for input 1, the output is 1 0. For the next message sequence is 1. So 1 means it has to reach downwards. So it is from S7. So if the input is 0, so it has to make an upward transition. So it reaches S6. So again we have the input 1. So it is 1 0. So rest all the inputs are 0 0. So now, so this part it is called as your tail of the tree. So how many extensions we need to make? So that depends upon n into m minus 1. That depends upon the encoder, that is with respect to n, k and m. So we all know how to extend the tail of the tree. So now looking into this code tree, or you can look into the state diagram, and from the state diagram we need to write a diagram which is called as the trellis, code trellis. So why we are going to use this code trellis here is that, so we have some advantages of using this code trellis or the trellis diagram. So here the complexity is more in representing the code tree, as well as writing the code tree is bit complex. So that's why in order to eliminate this complexity, that means to get the convolutional encoder in a very simpler way, or all the encoder codes what we have found out using the code tree, so that can be represented in a simpler form using this code trellis or the trellis diagram. So let us see how we can represent the same code tree with respect to the code trellis. As I told that, so we are going to represent this whole code tree in a simpler form using this trellis diagram. So where you can see here, so after some branches of the transition, that means from S0 to S1, so let us consider this is your first branch, so this is your second, this is your third, and this is your fourth, and this is your fifth. So that means once it completes 3 branches, so the states gets repeated. Okay. So now, so that means the sequence remains the same. So for that, what we are going to do here is that, so we have S naught state. So we know that, so we are having too many branches here. So let us write, so this is your first, second, third, fourth, fifth. So that means here we are going to consider these many states as j equals 0. That means here j represents the depth. Okay. So that means how many number of branches you are representing here with respect to the trellis diagram. So that is your j varies from j equals 0 to L plus m. So L represents the length of the message code and m represents the number of shift registers or the flip-flops what you are going to represent in the case of your encoder diagram. So now always when you are representing with respect to the code trellis, so the states, that means if suppose if you consider each state, so the S naught will be having 2 states, either it is 0 or 1. So always the 0 state will be represented, that is, this is with respect to input 0, they are indicated by dark line, that means by the thickened line. And S naught with input 1, so they are represented by the dashed lines. Okay. So now this is with respect to S naught state. So S naught with input 0 and input 1. So this is your first branch. So S naught with input 0. So it is reaching where? It is reaching the S naught state. So it is S naught state. So now S naught with input 1, where it is reaching? It is reaching S1. So let us consider that we have S1, S2, S3, S4, S5, S6 and S7. Okay. So these are the states what we have, that is 7 states we have. So this is for j is equal to 0. Okay, that is for the first branch. So now this is with input 1. So for input 1, where it is reaching? So it is reaching your S1 state of the second branch. Okay. So this is with respect to input 1. So what is the corresponding output? So the corresponding output is 1, 1. So this is for input 0. So what is the output? So for S naught with input 0, the output is 0, 0. Okay. So now here, so this is with respect to the second branch. So that means we have entered second branch, and whatever the message sequence we have, that is 11101. So it is going to start with respect to the second branch. So this gets again divided into, that means it moves to the third branch, fourth, fifth, sixth, seventh, like this. Okay. So now we are representing the trellis diagram only for the given message sequence, that is 11101, as well as for the extension of the tree. So now with the input 1, it reaches S1. So from S1, it is going to reach with respect to the third stage of S3. Means from S1, it is reaching S3 with input 1. So this is your branch 1, that is for j is equal to 0, this is for j is equal to 1, this is for j is equal to 3, this is for j is equal to 4, this is for j is equal to 5. Okay. So now from S1, it is reaching S3, S3 of the third branch. Okay, this is for input 1. So this is S3 with input 1. What is its output? The output is 0, 0. Next, so from S3, again the input is 1. So that it is reaching the next stage, it is S7. So this is for input 1. What is its output? So So its output is 1 1. Okay. So now from this stage, so with input 0 it is reaching S6. With input 0, so this is your S6. So S6 means with input 0 means it is a dark line. Okay. So S6 with output 0 0. Next from S6, so this is called as the extension of the tree. So that means after S6, so this is for with respect to input 0. So we got S6, and with input 1 it is reaching S5. With input 1 it reaches S5. So with input 1 it reaches S5. Okay, and corresponding to that the output is 1 0. Next. So this part, so this is S0. So this part is called as the tail of the tree. That means from here your extension starts. So that's why we have indicated by dashed line. So again this is S0. Okay. So now after that we have 3 extensions, that is from S5 it reaches S2. So where is S2? So this is S2 with input 0. So this is S2 with input 0. With input 0 the output is 1 0. Next, from S2 it reaches S4. S4 is here. Okay. This is also input 0 with output 1 0. Next. So from S4 it reaches S0. So this is with input 0 and output is 1 1. Okay. So this is how we are going to represent. So I have represented only the message sequence. So where you need to represent rest all of the branches or all of the divisions what we have done. So this is for, the first is for j is equal to 0. This is j is equal to 1, j is equal to 2, j is equal to 3, j is equal to 4 and j is equal to 5. Okay. So that means this is L minus 1, this is L and this is L plus 1, it continues. Okay. So this is how we are going to write the trellis, one way of writing the code trellis. So rest you can write the rest of the thing. So that is from S1. So if suppose if the input is 0, so if the input is 0 it reaches S2 of the third stage. S2 is this one, S2 of third stage means this one. Okay, this is for input 0. Next, from S2, if the input is 0, it reaches S4. So S4 is here. Okay, like this you need to complete everything. That means, so in my diagram I have represented only for the message sequence how you can write the trellis, how you can represent the trellis diagram. So but in general you have to write everything. That means for whatever the divisions you have done with respect to the downward direction, at least for 3 stages you have to represent in the trellis diagram. Okay. So first if you represent first 3 branches, then it's enough, more than enough, such that after 3 branches the next stages gets repeated. So that's why if you represent for first 3 branches, it's more than enough. Okay. So now I have represented for S1, S2 and S4 with input 0. Next for input 1, so you have, so from S1 it reaches S3, so where I have already represented. So now from S2 if you consider, so this is with respect to S2 in which stage? So it is with respect to the third stage. So for S2 with input 0, so with input 0 it reaches S4 of fourth stage. So this is S2, so it reaches S4 of fourth stage. that means this is your S2. So from S4, S2 to S4 it's already represented. So with input 1, S2 with input 1, it reaches 0, 1. That means it reaches S5. From S2, S2 of third stage, if the input is 1, it reaches S5. So S5 is here. Okay. So like this you are going to represent everything, whatever you have written in the code tree, the same thing has to be replicated, or the same thing has to be rewritten with respect to your trellis diagram. So this is how you are going to represent the trellis diagram. So where you can easily, that means it's very much easier when compared to your code tree. So but when you are representing with respect to the code trellis, so you have to either look into the code tree to write the trellis diagram, or directly from the state diagram you can also write the code trellis. So now let us look into an example where you can just look into the state diagram and write the code trellis in another simpler manner. Okay. Okay, we have an example here. So this is a state diagram which is given, so before writing the state diagram, so we need to follow the steps, like we need to write looking into the encoder diagram which will be given. So looking into that, so we have to write the state table, and that is to indicate that how many number of states we have, and along with that first represent the state table, and then from the state table we also need to write the state transition table indicating what is the present state, next state, and from the state transition table we are going to write the third step, that is the state diagram, and from the state diagram now the fourth step what we need to do is that we need to represent in the form of a code trellis. So this is the message input sequence which is given, and this is the N, K and M, that is the size of the encoder. So now, so if we consider this equation, that is N into L plus M, so N is 2, the length of the message sequence is 5, plus M is the number of adders, that is 3. So you are going to get 16 code bits. Okay, but how many number of code bits which we can represent from the given message? We can represent only 2, that is only 10 bits. So rest 6 bits, the extra bits what we need to add it here, so which we are going to get from the tail of the tree. So how we are going to represent the tail of the tree is by N that is N into M minus 1. So N is 2 here, M is 3, 3 minus 1, that means 4. Okay, that means additionally we need to add 4 bits for the extension of the tail of the tree. Okay. So now let us see how we can write the code trellis here. So how many number of states we have? We have 7 states. So S0, S1, S2, S3, S4, S5, S6 and S7. Okay. So with each state, so we have input 0 as well as input 1. So now if we look into the given message sequence, so here if we consider this message sequence, so what could be the transition? So it starts from 1, that means S0 with input 1, it reaches S1, that means from S0 it moves to S1, S1 with input 0, so S1 with input 0, it reaches S2, next with input 0, from S2 with input 0, so it reaches S4, then from S4 with input 1, so it reaches S0, then from S0 with input 1, so it reaches S1. So rest is you need to append zeros for the extension of the tail of the tree. So that means 3 additional bits we need to add. So from S1 with input 0, so it reaches S2. Again with input 0, so it reaches S4. Again with input 0, from S4 with input 0 it reaches S0. Okay. So this is how we are going to write the transition by looking into the message sequence. So we have a small change here. So with the transition we made a small mistake here. So from S4, that means, so this is for S0 with input 1, it reaches S1. Okay. So then with input 0 it reaches S2. Next with input 0 it reaches S4. Okay. Next is input 1. S4 with input 1 is S1. Okay. Next input is 1. So for input 1 it reaches S3. So additionally we need to extend the tail of the tree. S3 with input 0. So it reaches S6. Again input is 0. It reaches S4. Again from S4 input is 0. It reaches S0. Okay. So this is called as your tail of the tree. Okay. So this is the transition diagram. So now the same thing we are going to represent the code in the code trellis. So this is for S0 with input 0. With input 0 it reaches S0. So here we have the same stages, S2, S3, S4, S5, S6 and this is your S7. So for all the cases we have input 0 as well as input 1. So always the input 0 is indicated by a thickened line and with input 1 by dashed lines. So here S0 with input 0. So it reaches S0 state with corresponding output 0, 0. So now let us represent only the message sequence now. So S0, so with input 1 where it is reaching S1 state. So this is input S0 with input 1, what is the output? It is 1. Okay. Next. So from S1, so after that we have, from S1 we have S2. So it is S1 with, what is the next input? So this is for S0 with input 1, this is for input 0. So next S2 with input 0. So S2 with input 0. So now with respect to S1, so we have once again, so from S1, so we have input 0, it reaches S2. Okay. So this is 0 with output 1, 1 and S1 with input 1, it reaches S3. One, 0, 0. If we consider with respect to S2, S2 with input 0, it reaches S4. So S2 with input 1, it reaches S5. Input 1, output is 1, 0. Next, with respect to S3, S3 if it is input 0, it reaches S6. So 0 with, so S3 with input 1, it reaches S7. Okay. The output is 0, 1. Next, if we consider S4, so this is your S4. S4 with input 0, it reaches S0. Output is 1, 1. So with input 1, it reaches S1. output is
0, 0.
Next, if we consider S5, so with input 0, it reaches S2. It is with respect to S5. Output is 0, 0. So S5 with input 1, it reaches S3. This is for 1, output is 1. Next with S6. S6 with input 0. So input 0, it reaches S4. Output is 1, 0. S6 with input 1, it reaches S5. 1, output is 0, 1. So now with respect to S6, if it is input is 0, it reaches S6. Output is 0, 1. So if the input is 1, it is self. This is for 1, the output is 1, 0. Okay. So now the state diagram I have written completely in the Trellis diagram. So now you need to represent this same sequence in this manner. So from S0, it makes a transition to S1. From S1, so what is, it has to make a transition to S2. Okay. So from S1, it has to make a transition to, from S1 to S2. So this is for input 1, this is for 0, this is for 0, 1, 1, and these are all zeros. Okay. So this is for 1, 0, 0, 1, 1, 0, 0 and 0. Okay. So from S0 to S1, we already have a transition. From S1 to S2. So from S1 to S2, then we have S2 to S4. So S2 to S4, it's already represented. Then S1 to S3. So from S1, so we don't have S3 here. Okay. S1 to S3, then S3 to S6. So S3 to S6 we don't have here. So this is S3 to S6. Then from S6 to S4, so we have S6. So already we have a connection from S6 to S4. Then from S4 to S0. So S4 to S0 also we have a connection. Okay. So this is another way of representing the code trellis by looking into the state diagram. So this completes the 5th module. Thank you.